Greetings to all my dear students, hoping that you all are safe and sound. Let us continue with Lesson 1, Chemical Reactions and Equations. In the last class, we discussed about three types of chemical reaction. First, combination reaction, decomposition reaction, and displacement reaction, also known as synthesis reaction. Two or more reactants combine to form a single product. Decomposition reaction, reverse of synthesis of combination reaction, one where a single reactant breaks down to form two or more products. Displacement reaction, which is also known as replacement or substitution reaction, where a highly reactive element displaces the less reactive element from its solution to give new products. Today we'll start with fourth type of chemical reaction, double displacement reactions. The reactants and products are represented here as ABCD and ADCB respectively. Two reactants are involved, which results in formation of two products. Two ionic compounds exchange cations. Double displacement reactions are the reactions where elements in different compounds exchange places, producing two new compounds simultaneously. The positive ions of two ionic compounds switch places and make two new ionic compounds. Ionic compounds are the compounds formed of ions, where cation is formed of metals, anion is formed of nonmetals. The example shows the aqueous solution of barium chloride and the aqueous solution of sodium sulfate react, and during double displacement reaction, the two positive ions of the two ionic compound switch their places. Thus, sodium being highly reactive pushes barium from its aqueous solution and takes its place, forming sodium chloride. It is also in aqueous solution. Barium, removed from the aqueous solution of barium chloride, is being attracted by the anion sulfate ion and combines to form barium sulfate in the solid state. This can also be represented as AB, the reactant 1, CD, reactant 2, where A and C are cations or positive ions. B and D, whereas are anions, negative ions. After the switch of the positive ions, the product formed are CD and AD respectively. Double displacement or replacement reactions are also referred as metathesis reaction. The two compounds exchange ions to produce two new compounds. It is easier to simply remember that the cations or positive ions exchange anions or negative ions. Kindly do specify that we always write the cation first, then the anion. Many reactions, including precipitation and neutralization, use the double displacement mechanism. When we consider displacement and double displacement, both refers to substitution of one or more entities between the reactants, forming the new products. But there are some differences also. A displacement reaction is a chemical reaction where a chemical species in a molecule is replaced by another chemical species, whereas in double displacement reaction involves the exchange of two ionic species between two different molecules. Only one chemical species is displaced in displacement reactions, whereas two chemical species are displaced in double displacement reactions. One chemical species is replaced in displacement, two chemical species are replaced in double displacement. Displacement reactions are based on the reactivity of chemical species, whereas double displacement reactions are exchangeable ions which are included in the compounds present in aqueous state. There are two different types of double displacement reactions on the basis of the nature of reactants and the products obtained. The first one is neutralization reactions. A neutralization reaction is a reaction where an acid and a base produces a salt and water. A salt is an ionic compound made up of cation from the base and an anion from an acid. Like for example, hydrochloric acid reacts with sodium hydroxide. Here, the salt is formed as sodium chloride along with water molecule. In the salt sodium chloride, sodium is the cation obtained from the base sodium hydroxide and chloride is the anion obtained from the acid hydrochloric acid. During a neutralization reaction, an acid and a base react to produce a salt and water along with the release of heat. So most of the neutralization reactions are exothermic reactions. Salts are ionic compounds consisting of an anion from an acid and a cation from a base. Two more examples are sulfuric acid reacts with sodium hydroxide to give sodium sulfate, the salt, along with water molecule. Example 3, hydrochloric acid reacts with calcium hydroxide to give calcium chloride, the salt, and water molecule. Second type of displacement reaction is precipitation reaction. We have already studied about solution, suspension. When the suspension settles down, it forms precipitate. Precipitate, what is it? Compounds which are unable to dissolve in liquid solutions and forms a solid is a precipitate. Chemical reaction in which precipitates form are known as precipitation reactions. The double displacement reactions occur which results in formation of an insoluble solute and along with that another product is precipitation reaction. Like for example, silver nitrate in the solution when reacts with magnesium chloride in an aqueous state turns into formation of solution of magnesium nitrate along with a precipitate silver chloride. As these are the examples of double displacement reaction, we now will start with oxidation and reduction reactions. These reactions are also known as redox reactions, which involves oxidation and reduction taking place or occurring simultaneously. The redox, the name itself comes from these two words. The red is from reduction and OX is from oxidation reaction. Oxidation and reduction are studied in terms of first loss or gain of oxygen, loss or gain of hydrogen, transfer of electrons, and changes in oxidation number. We first will see oxidation. It is combination of substance with oxygen, loss of hydrogen, loss of electrons, and subsequently an increase in oxidation number. Whereas reduction involves removal of oxygen from the substance, gain of hydrogen, gain of electron, and subsequently decrease in oxidation number. Few examples. Number one, when copper oxide is heated with hydrogen, then copper metal and water are formed. What equation is copper oxide plus hydrogen gives, represented by an arrow, copper and water molecule. Formula equation is CuO plus H2 gives Cu plus H2O. If we see the formula equation, each and every element are having equal number of atoms to reactant and product side. Hence, this is a balanced chemical equation. Oxygen is seen removed from copper oxide to form copper, and this is reduction process. Oxygen at the same time is added to hydrogen to form water, and the process is oxidation. The agent or the substance copper oxide supplies oxygen in the reaction is the oxidizing agent. Hydrogen, on the other hand, is reducing agent. Thus, reduction reaction can be explained as with the aspect of gain and loss of oxygen. Oxidation is gain of oxygen, reduction is loss of oxygen. With the aspect of loss or gain of hydrogen, oxidation is loss of hydrogen, reduction is gain of hydrogen. With the aspect of gain or loss of electron, oxidation is loss of electrons and reduction is gain of electrons. And finally, with the aspect of increase or decrease in oxidation number, oxidation is increase in oxidation number, reduction is decrease in oxidation number. Agents. Reducing agent loses electrons and also oxidized by another element, thus becomes more positive. Oxidizing agent, on the other hand, gains electron and is reduced by the other element, becomes more negative. These are the common terminology for reduction. Oxidizing agent is electron acceptor. The species that is reduced. Reducing agent is the electron donor. The species that is oxidized. Active metals lose electron easily, therefore are easily oxidized and are strong reducing agents. Active nonmetals, on the other hand, gain electrons easily, therefore are easily reduced and are strong oxidizing agents. Another example of redox reaction is the reaction between magnesium metal and hydrochloric acid. The loss of electron by examples of redox reaction in daily life. There are n number of examples of redox reaction in our daily life which do have advantages as well as disadvantages. Like we say, there are two sides of a coin. Similarly, oxidation reduction reactions are important for us, and these do have significant role in number one, photosynthesis. Water is oxidized to release oxygen gas, and carbon dioxide is reduced to glucose, which is used as fuel to metabolic reactions of plants. It is having also role in metabolism of our body. Oxidation can also be considered to be gain of oxygen, loss of hydrogen in a molecule, and respiration is the redox process where living organisms oxidize food to release energy. The use of breath analyzers and bleach are also on the basis of redox reaction. Cops often use breath analyzers, which once used by a driver, which gives breath into it. An acidic solution of potassium dichromate reacts with it. The ethanol in the breath is oxidized to acetic acid, whereas the chromium 4 in the orange yellow dichromate ion is reduced to chromium 3 green in color. The amount of color change corresponds to the levels of alcohol in the blood. The bleach has the ability to whiten or decolorize substances. Decolorization occurs due to the electron movement between different energy levels. This can be reversed by oxidation, decomposition, and combustion. The living matter in nature is made up of carbon, hydrogen, and oxygen, and upon death of these organisms, the organic compounds present in the body react with the oxygen of our surrounding in a prolonged process as decay or decomposition. Burning or combustion allows oxygen to bond with carbon and hydrogen. Oxygen present in the atmosphere is being reduced, whereas the compound undergoes oxidation in the process. Oxidation, which allows the combination of oxygen with the substance, also do have some of the disadvantages also. Like for example, rusting of iron and oxidation of metals. Oxygen even reacts with food items, the food items which contains fats and oil. If they are left out in the air for few days, they start to smell unpleasant. They turn rancid and inedible. This is due to the oxidation of fats and oil. It is known as rancidity. Methods used to prevent oxidation of food involves the use of antioxidants, chemicals which slow down the oxidation of fats and oil in the air, the use of vitamin C, which is present in the citrus fruit, is already a natural antioxidant, and the use of inert gases like nitrogen filled in unopened packets of chips. Nitrogen prevents oxidation of chips. Once the packets are open, antioxidants in the food prevents oxidation. Rusting, the slow conversion of iron into its hydrated ferric oxide in the presence of moist air is called rusting. This results in formation of hydrated ferric oxide. The number of water molecules X is variable and is not fixed depending upon the moisture or humidity of the air. Other metals also do show corrosion. When aluminium or zinc is exposed to air, the metal on the surface react with oxygen in the air to form their oxides. These oxides do not flake like rust but form protective surface on metal. When silver is exposed to air, a black coating of silver oxide is formed on it. This is called tarnishing. This can be removed by polishing. Bronze, alloy of copper and tin, develops green film due to oxidation over long time. This coating is called patina. Copper is used as roofing material. Over time, the copper surface reacts with carbon dioxide in the air to form a green coating called verdigris. This is copper carbonate hydrated. The rusting and the rancidity of food items are harmful to us, therefore needs to be protected. Rusting and corrosion of metals results in degradation of quality of metals, so can be prevented by oiling, greasing, galvanization, and making alloys of the metals. With this, we have completed lesson 1. In our next, we will see the exercises related to it, which describes the various types of reactions and ways to write the reactions.